Hello everyone, welcome back to another video tutorial in integral calculus, and in this video we will learn how to integrate functions that can't be integrated using the basic integration rule. So we have techniques that we will be using, that is the integration by parts. Okay, so integration by parts can be applied especially when we have functions combined, or functions that are different in nature and they are combined into one function. Okay, so like for example, if we have exponential function and we have trigonometric functions combined, then they cannot be used, or they cannot be integrated using the basic integration rule. So by parts can be used for a complex function. So what is the form of by parts? So we have here the integration by parts form, that is, we have the integration of u dv is equal to uv minus the integration of v du. Now, the first thing we do here in integration by parts is to determine which is u and dv in our function. So we might find it very difficult to determine which is u and which is dv. Okay, but I have a mnemonics to remember, okay, to such a criteria lang on what or which u should be used. So I have the what we call the layet, where in our L here, this is the logarithmic function, and I here is the inverse trigonometric function, and A here is the algebraic function, T is the trigonometric function, E here, that's the exponential function. Okay, so our u here is whichever comes first in our list layet. Okay, so let's try to solve problem. I have here the integration of x e raised to x dx. So we have two different functions. We have function that is x, that is algebraic, and e raised to x, that is exponential function. Again, the by parts formula is we have the integration of u dv is equal to uv minus the integration of v du. Okay, we need to identify which is u in the function and which is dv in the function. So again, we can have the layet. Now we have two functions, that's the algebraic and the exponential function, and we can see here that the first function that comes in the list is a, or that's the algebraic. So therefore our u here is x. So our u here is x, and the remaining one would be our dv, okay, from the form u dv. So our dv here, that is e raised to x dx. So this one is our u, and this entire remaining term is our dv. So we have the derivative of u, that is dx, and now we need to identify the value of v, since from our by parts formula we have v here. So how are we going to determine the v? Now take note, we just need to integrate this one, and by integrating we have v is equal to, if we integrate ex dx, then we still have the value of e raised to x. Okay, then we should have plus c here. But since we are using plus c in this form, then we cannot include c na lang. Okay, so we have here our value of u and the value of v, and we have the du. Then we substitute all of this value in this form. So we have here our u. Our u here is x. Our v, this v here, that is e raised to x, minus the integration of our v here. Now take note, our v is e raised to x. Then our du here is dx. Okay, so we have x e raised to x minus, if we try to integrate e raised to x dx, then we still come up with e raised to x, correct? Then don't forget plus c. So by further simplifying, we can factor out e raised to x. So we have e raised to x. The remaining would be x minus 1 plus c. So this is the integration of x e raised to x dx. Okay, we have another example. We have the integration of x sine 2x. So we have two different functions, and upon looking at the equation or the function, we cannot use power rule or trigonometric rule to apply in this function. Again, since if we apply trigonometric rule, we have u is 2x, then our du should be 2dx. However, we have x here in the function. Okay, so we cannot apply trigonometric rule. So in this case, we can apply the by parts, that is the integration of u dv is equal to uv minus the integration of v du. So again, we need to identify which is u and which is dv. So from the word layet, so we have two functions. We have the algebraic functions and we have the trigonometric functions. So as what we can see here, our algebraic function comes first before our trigonometric function. So therefore, our u is equal to x. So therefore, our derivative of u is dx. So the remaining, if this is our u, then all of this one is our dv. Okay? So therefore, our dv is equal to sine 2x dx. Now, we need to identify v by integrating dv. So we have v here. If we integrate sine 2x dx, since this is from the equation sine u du, from the integration rule, sine u du, and then we have the integration of that is equal to negative cosine u plus c. Now, in that case, our u is 2x, then our du should be what? 2 dx. Okay, so we can this our u, our du should be 2 dx, so we multiply 2 here and then 1/2 outside. So therefore we have 1/2, that is negative cosine of 2x plus c. Correct? So this one is the integration of sine 2x dx. Okay, and we have the value of v here, that is negative 1/2 cosine 2x. Again, we may not include the arbitrary constant c. So we have here, or we can now substitute this u and v and du in the by parts. So we have our u here, our u is x, okay, and our v is negative 1/2 cosine 2x. So therefore times negative 1/2 cosine 2x minus the integration of, we have v, that is negative 1/2 cosine 2x times our du. Our du here is dx. So times dx, so we have here negative x over 2, correct, by algebraic operation, cosine 2x. Then we can take 1/2 outside of our integration, but take note, we have negative outside and we have negative inside, then we can multiply them. We have negative times negative, that gives us positive 1/2 the integration of cosine 2x dx. Now take note, we need to integrate cosine 2x dx here, and we know that the integration of cosine u du is equal to sine u plus c. Now in this case, this is our u, our du should be 2 dx, correct? So since our u is 2x, our du should be 2 dx. So we have here 2 dx, but since we are lacking of 2, we multiply 2, then times 1/2 outside of the integration to balance the equation. So we have here, that is, just copy the first term, plus 1/2 times 1/2, that gives us 1/4. Then this one, that is sine, correct? sine of 2x plus c. So therefore, this one now is the integration of x sine 2x dx using by parts. We have here another example, that is the integration of x raised to the 5 cosine x cubed dx. That is, we have two functions here that are different combined into one function, and we have the algebraic functions and we have the trigonometric functions. Okay, so by checking at Layet, we can see here that our algebraic function comes first before the trigonometric function. Therefore, our u here is equal to x to the 5. However, if we let the entire u, or we let the x raised to the 5 as our entire u, we may find it very difficult to integrate dv. Sige, if this is our u, then this entire term here is our dv. So we have dv here, that is cosine x cubed dx. Now again, since we need to determine v from the by parts formula, that's the integration of u dv is equal to u v minus the integration of v du. Take note, we need to compute for v, and the only thing that we have here is that, but if we integrate dv, or the integration of cosine x cubed dx, take note, this integrand here, or this cosine x cubed dx, can't be integrated using any trigonometric rule or power rule. Take note, we have x cubed as its angle. So therefore, if this one is our u, if our u is x cubed, so therefore we need du here as 3x squared, correct? However, we do not have x squared alongside with cosine x cubed. Okay? So we need x squared inside our integrand. So how are we going to evaluate this one? So in this case, we can actually break x raised to the 5 in two terms. Okay? So we can say that it is, since we need x squared beside cosine x cubed, then we can separate x to the 5th into x cubed times x squared cosine x cubed dx. Okay? So in this case, this is our u, and this entire term now is our dv. Okay? So if our u here is x cubed, then our du here is 3x squared dx. Now our dv here is equal to x squared cosine x cubed dx. So if we look for our v here, then we can integrate this one. Let's try to integrate x squared cosine x cubed. So we could have the integration, that's v is equal to the integration of x squared cosine x cubed dx, wherein our u here is x cubed and our du here is 3x squared dx. Correct? So therefore, we can say that it is v is equal to the integration of cosine x cubed times x squared dx, wherein this one here is our u and this one is our du. Now take note, we are lacking of 3 to satisfy our required du, which is x squared dx, then 3. So we multiply 3 here, and outside we multiply 1/3. And now we satisfies the rule, that is the integration of cosine u du is equal to sine u plus c. So therefore, we have our value of v here, that is 1/3, that is sine of x cubed plus c. So this one is the integration, or our value of v. Now what if we use U-substitution? So U-substitution, again, we need to change our function of x into function of u. Okay? Wherein our x cubed here is our u, and du should be 3x squared dx. Now again, we can express that one as dx is equal to du over 3x squared. Correct? So therefore, from our v here, it is the integration of x squared cosine x cubed dx. Then we have v here is equal to copy x squared. Then that is cosine at our x cube here, that is u. Correct? Then our dx here is du over 3x squared. So we have du over 3x squared. So from this form, that is the value of dx. Okay? That is du over 3x squared. So therefore, we can say that it is v is equal to, now take note, we can cancel out x squared, and the remaining would be 1/3. We can take 1/3 outside of the integrand. We have 1/3 the integration of cosine u du, and we know that our cosine u is equal to sine u plus c. Then we get back the function of x in this equation, and we know that the u here, that is x cubed, so v is equal to 1/3 sine of x cubed plus c. So this is the value of our v. Okay? So therefore, we will be using this v here in our by parts. So again, you can use either of the two approach. Okay? So it's up to you, whichever is convenient to you. Okay? So we now go back to our original problem, that is, we know that the value of v here, that is equal to, from the previous, or from the integration that we had, that is 1/3 sine x cubed. Okay, so this is the value of v. Now we are going to use this u, dv, and v in our by parts. So we have here our u is x cubed times our v, this one is v, correct? Our v is 1/3 sine x cubed minus the integration of our v is 1/3 sine x cubed times our du, this one is du, that is 3x squared dx. Then we have, by further simplifying, we could have 1/3 x cubed sine x cubed minus this one here. We can multiply 1/3 and 3. Okay, but I opt to move 1/3 outside of the integration, since this 3 here may be useful in integrating sine x cubed. So we have the integration of sine x cubed times 3x squared dx. So we can integrate sine x cubed here, by which our u is equal to x cubed, our du is 3x squared dx. Okay? If this is our u, so this entire term is our du. So we have already satisfied the required du. So we can now directly use the integration rule, that is the integration of sine u du is equal to negative cosine u plus c. Okay? Or you can use, again, U-subsitution, but it might be very long na. So you can directly use this one. So we have, to further simplify, that is 1/3 x cubed sine x cubed, just copy the first term, minus, in this case, we have 1/3 times the integration of sine x cubed 3x squared dx, that is, we have completely satisfied the sine u du rule here. So we directly use this negative cosine u plus c, that is negative cosine of our u. Our u here is x cubed plus c. Okay, so we have now the answer, that is 1/3 x cubed sine x cubed. Since we have negative inside the bracket and we have negative outside, then we can multiply them, that is, we could have plus positive. Then positive 1/3 cosine x cubed plus c. Or we can factor out 1/3 1/3 here, that is 1/3. The remaining would be x cubed sine x cubed plus cosine x cubed, then plus c. So the final answer will be any of these two. So we have here our answer, or that is the integration of x raised to the 5 cosine x cubed dx. Now we have last example here, that is the integration of ex cosine x dx. So again, we cannot apply any integration rule to this one since we have two functions that are different and they are combined into one function. So our functions here, we have the exponential function, we have here the exponential function, and we have the trigonometric function. So by checking using the Layet mnemonics, so we have our e here and our trigonometric, and we have seen here that trigonometric function comes first before the exponential function. So therefore our u here is equal to cosine x. Okay, now the remaining would be our dv. So if this one is our u, so this 2 here is our dv. So we have dv here is equal to ex dx. And then our du here is equal to the derivative of cosine x, that is negative sine x dx. And then to determine the value of v, so we just need to integrate this one, and that would give us v, and then the integration of e raised to x dx, that is the same as e raised to x. Okay, we integrate e raised to x, that is e raised to x. Then we substitute the value of u, du, and v here in our by parts form, and that is uv minus the integration of v du. First, we substitute the value of u. Our u here is cosine x, times our v is e raised to x, minus the integration, our v is e raised to x, times our du is negative sine x dx, so we have negative sine x dx. So we simplify it further, so we have e raised to x cosine x. Now take note, we have negative inside the integration and we have negative outside the integration, so we can multiply these two, then we could get positive. So what positive? The integration of e raised to x sine x dx. Now take note, this integration here, ex sine x dx, can't be integrated or can still be integrated using the existing integration rule. Okay, since we still have e raised to x, which is the algebraic, and sine x dx, which is the trigonometric function. So what we're going to do here is to apply by parts. So we still be applying by parts here. Okay, so in this case, so let's isolate integration of e raised to x sine x dx. So we apply by parts. So our u here is sine x, then our dv is ex dx. So our du here is the derivative of sine x, that is cosine x dx. Now our dv, now our v here is the integration of ex dx, and that gives us the same value, which is ex. Okay, so we apply uv minus the integration of v du here, that is the integration of u dv. So this gives us our u here, that is sine x, correct? Our v here is e raised to x, minus the integration of our v, that is e raised to x, our du, that is this one, cosine x dx. Or we could say that is ex sine x minus the integration of e raised to x cosine x dx. So let's substitute it back to our equation. And then we have here, copy the first term, plus, since the integration of ex sine x dx is this one. So we copy this one, that is plus e raised to x sine x minus the integration of ex cosine x dx. Okay? However, take note, integration of ex cosine x dx is the same as with our original function here. So therefore, we can't still integrate this one unless we apply by parts again. Okay? If we apply by parts, then it will lead us back to ex sine x dx. So it would be an iterative procedure. So paulit-ulit. So we have to stop. Okay? So when are we going to stop in this case? So take note, we know that this equation here is equals to the integration of ex cosine x dx, correct? Which is at the left side of our equation. So actually, this one here is similar to our original function, therefore we can combine them. Okay? So we transpose this term to the left side, so we have the integration of ex cosine x dx. We can transfer this term to the left side. We have plus. So the sign will change because it is negative here, therefore it would become positive. Integration of ex cosine x dx. And this gives us the remaining, which is this term, that is e raised to x cosine x plus e raised to x sine x, then we have plus c. Okay? Now, if we combine these two terms, take note they have coefficient of 1. So, you combine them, we could have 2, the integration of e raised to x cosine x dx. Okay, that is e raised to x cosine x plus e raised to x sine x plus c. So, we divide both sides by 2. We could have here the integration of ex cosine x dx is equal to 1/2 times e raised to x cosine x plus sine e raised to x sine x plus c. So our c here will remain c, since if we multiply constant c times constant 1/2, that will give us constant itself. So by further simplifying, we have integration of ex cosine x dx is equal to, now we can take e raised to x outside, we can factor it out. We have e raised to x over 2 times the remaining inside the parenthesis, that is cosine x plus sine x plus c. Okay? So therefore, this is now the integration of e raised to x cosine x dx. Okay? So in this type of problem again, if our by parts or integrating by part is or becoming iterative or paulit-ulit, then you need to have a timing, or you need to find a timing when to stop. Okay? So you need to find that our last integration here is the same as with our original function. Okay? So you need to combine them, you need to add them. Okay, just like what I did in this process. So that's it for the integrating functions using by parts. So if you have questions, clarifications, you can comment it down. But for more videos, please don't forget to like and subscribe. Thank you so much for listening.